All right, I'm going to try to pick up where I left off yesterday. Come in early on your 2-hour delay to try to finish this up, so I hope you appreciate it. Try to give you a better video for your review. So we're picking up here with question number 22, two vertices of a parallelogram. So obviously we want to remember some things about parallelograms. We want to spend some time there in lesson 34 talking about properties of parallelograms. What we're going to need here, you'll notice, always want to pick out these important words: parallelogram, intersection of diagonals, because we're going to need to know some things about diagonals in this. If you remember, diagonals in parallelograms bisect each other. All right, so I'm going to take us over to a coordinate plane here in just a second. You should have these numbers 2, 3, 8, 11 that are going to intersect at 7, 6. So I'm going to pull that up with our coordinate grid here. All right. So I'm going to take a coordinate grid, and if you get a question like this on your test, by all means, coordinate paper, grid paper will be available to you. All right, so let's go ahead and plot these vertices of this parallelogram. The first one we have is at 2, 3. So we're going to go 1, 2, 1, 2, 3. All right, so that's A at 2, 3. It's right there. Let's get my other one at 8, 11. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and then we have where their diagonals are going to intersect at 7, 6. Let's pick a different color for that. 7 should get me to there. 1, 2, 3, 4, 5, 6. All right, so if I'm going to connect these, okay, probably should have picked a different color than that. That's okay. But what we're saying is that this diagonal is going to come across here, and this diagonal is going to come across here. We want to know what the other two vertices of this parallelogram are. So the important thing to remember is that in a parallelogram, diagonals bisect each other. So the slope or the distance is going to be consistent, which means, if I do this, all right, I want you to look at this black line here. From the red dot to the blue dot, okay, it's going up 1, 2, 3, 4, 5 over 1. All right, so up 5 over 1, and I could use Pythagorean theorem and get the distance of that because that black line is only half of the whole of the black line. So actually what I can back the rest of it. So 1, 2, 3, 4, 5, 1. It's going to give me that next vertex. All right, because we should see that this line, okay, would continue on, okay, the rest of that length. So that, let's see, that coordinate is going to be 1, 2, 3, 4, 5, 6, 6, 1. Okay, let's see, and we could finish that up. We get that right there. Now, there's a couple of different ways that we could find the next one. We could go and look at the distance from point A to the new coordinate that I've looked at, but let's stay consistent with our diagonal from A to X. Okay, let me put our other coordinate up here. This was B at 8, 11. Okay, let's see. This point is X at 7, 6. Okay. All right. Now, there are other mathematical ways to do this. For instance, because X is a midpoint, we could have used 7, 6 as the answer to the midpoint formula. Let me show you what I mean by that real quick. Okay, what I mean is that that 8, let's see, my midpoint formula is x1 plus x2 divided by 2 equals that midpoint x coordinate, so midpoint x. Okay, so knowing that we've got 8, what we're saying is that 8 plus x divided by 2, okay, is going to equal 7. All right, and I'm going to multiply by 2 on both sides. okay? And I'm going to get 8 plus x equals 14. Then I'm going to subtract 8. So I'm going to get x equals 6. And you'll notice that that matches that right there. Then I would do the same thing with the y coordinates. Okay? So instead of x1 plus x2, we're going to do, let's see. If you can't tell, I've got a cold, so my brain isn't really working too well today. Y1 plus y2, okay, is going to equal my midpoint y coordinate. And because I only have 1, I'm going to do 11 plus my unknown y divided by 2 equals my known midpoint coordinate, which is 6 in this case. So I'm going to do the same thing, multiply by 2 on both sides. I'm going to get 11 plus y equals 12. Okay? Subtract 11 from both sides. I'm going to get y equals 1. Okay, again, you see that right there. So we can actually solve for the last midpoint, or sorry, the last coordinate using the midpoint formula. Or, like I said, we can go up 1, 2, 3 over 1, 2, 3, 4, 5. Okay, so I know from here I'm going to go up 1, 2, 3 over 1, 2, 3, 4, 5 and just match that slope. Okay. If I've done everything right there, 2, 3, 1, 2, 3, 4, 5. I want to check it again. 1, 2, 3. 1, 2, 3, 4, 5 looks right. Okay, and we can look at our coordinate. Coordinate there should be, let's check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it looks like we're at 12. And 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 12, 9. All right, 12, 9, and 6, 1 are my coordinates. All right, like I said, you could go ahead and you could use that midpoint formula again there. If you're going to do the Pythagorean theorem way of just kind of counting rise over run and continuing that through, you just need to use a sheet of graph paper to show me what you're doing. That way I know that you know what you're doing and it's not just coming out of nowhere. Okay. All right, let's move on to question 23. Okay, question 23. All right, Jenny's birthday cake. Let's see, this is lesson 35, finding arc length and area of a sector. And really, we've already done area of a sector. So a reminder, that formula is pi r squared times measure over 360. We want to know the area of that slice of cake, but not the volume. And that's what's kind of confusing about it. So you wouldn't necessarily just find the area of a slice of cake, but if you're looking at it from a bird's eye view. So what you're looking at technically here is they're telling you that we have something like this. So 12 is my radius, 30 degrees is the arc itself. So we're using, and we're solving this in terms of pi, so we see right there. So we're doing 12 squared, because that's my radius over 30 over 360. And so rather than calculating pi, okay, we're going to leave pi out. So we're going to use 12 squared, 30 divided by 360, and it's always a smart move to go ahead and check your mode and make sure it's in degrees, okay, before you get the wrong answer. And so I end up with 12 pi centimeters squared. Okay, because we want to solve our answer in terms of pi, so we want pi as part of my answer, 12 pi centimeters squared. Anytime that they ask for an exact answer, they're going to want it in terms of pi, because 3.14, 22 over 7, any of those types of things are approximations. Okay, they're estimates. So if we want to solve for something exactly where pi is involved, we leave it in terms of pi. Okay, the same way anytime a radical is involved. If we want an exact answer, we leave it with the radical in there. All right, number 24. We've seen this question type earlier for these triangles, selected triangle congruency statement and the postulator theorem that supports it. It's a different theorem that proves it, but the same type of congruency statement. So they're going to start off with every one of your answers should be triangle LMN is congruent to triangle what? Okay, so now we're looking at corresponding parts. What corresponds to L? Well, that's V. What corresponds to M? T. What corresponds to N? U. And because they're right triangles, chances are what this is going to end up being is that ML is a leg and LN is a leg. Because they're right triangles, we're going to use leg, leg. Now, because they're triangles, period, and I have my angle here is included, I could also state that this is side angle side. They won't give you both, okay? They're not going to try to confuse you necessarily that way. Obviously, it's not angle, side, angle. It's not side, side, side. It is only leg, leg, or side angle side based upon what has been given to me. So be careful as you look at that. Be careful here. Okay, match that up. So long, and you can eliminate any answers right off the bat that aren't triangle LMN is congruent to triangle VTU. Okay, so start there and then look at those congruency statements. Okay. And if you need a reminder on where those congruency statements are, and you should look them up, it's lesson 36, right triangle congruency theorems. Let's come down to number 25. Number 25 we've seen on tests before, and I think I've given you guys instructions on what kind of work to show. But you need to show your slopes because what you're trying to identify is parallel and perpendicular lines. We identify parallel and perpendicular lines by associating their slopes. Lines that have the same slope are parallel, lines that have opposite reciprocal slopes are perpendicular. Biggest thing that people forget is that it has to be both opposite and reciprocal in order to be perpendicular. So you need a positive, negative, and then the flip of the fraction. All right, so let's start with GF, segment GF. So I'm going to show you exactly the work that I would show. That's going to go up 3, 1, 2, 3, over 1, 2, 3, 4, 5, 6, 7, 8, 9, it looks like. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, sorry, 8. 3/8 is my slope there. All right, so that's GF. Let's do HD. HD, if you'll notice, is only going up 2 over 8. So 2/8, which is going to reduce to 1/4. You can't do this simply by looking at it, because if you just look at it, would you just look at it? Just go ahead and look at it. Would you look at that? Okay. Sorry. But a lot of my students have a tendency to just look at 2 lines without trying to do any work and just say, hey, those look parallel, without looking really closely at it because we get pressed for time. And so we make quick assumptions and end up saying things like GF is parallel to HD when in fact they have 2 very different slopes. Okay, IC. Okay, and there is another way to kind of show your work for slopes. You could go ahead and get the coordinates for G and F, right, and do your y2 minus y1 over x2 minus x1 and get that same 3/8. Be a lot more work. It'd be right work, but I understand that you're pressed for time, so I'm trying to show you the quickest way to do this, so at least show me the fractions of those slopes. Okay, and they need to be accurate. You'll notice that IC goes up 1, 2, 3, so that's a good sign. It seems to go over 8, so it has a slope of 3/8. Okay, we look at, what was it, ED? ED has a slope of, looks like it goes up 1, 2, 3, 4, 5, 6, over 1, 2, 3, 4, 5, 6. So it really has a slope of 1 because it's going up 6 over 6, so the reduced fraction is just 1. And finally, AB, segment AB, has a negative slope from A to B, so it's going down 1, 2, 3, 4, 5, 6, 7, 8. It's going down 8 over 1, 2, 3. Okay. All right, so my 2 lines that are parallel are my lines that have the same slope, so I should say that GF and IC are parallel. And my opposite reciprocal is GF and AB, they're opposite reciprocals, so GF is perpendicular to AB. And because IC and GF are parallel, they're both going to be perpendicular to the same line. So what we're looking for is something that looks like this GF is parallel to IC, and GF is perpendicular to AB. But not only that, but IC is perpendicular to AB as well. Those are the three statements that we need out of that, based upon those slopes. So that's the work that you need to show. Okay, let's see, let's find question 26. Okay, come back up here. All right, question 26, coming out of lesson 39, inequalities in a triangle. This is where we have to go back and remember that the sum of any two sides of a triangle has to be greater than the third side length. And so here we're actually going to find a range of possible values so that the AH connects AD, or connects to AD and DH with no overlap. So the range of distances. So the first thing I'm going to do is I'm going to say, well, 200, 240 has to be greater than AH, and then I can solve that so that I know that 440 has to be greater than AH. Okay, the second thing I need to know is looking at this side right here, that these two sides need to add up to be greater than DH. So 200 plus AH has to be greater than 240. I can subtract 200. So AH has to be greater than 40. Okay, it could be 41, it could be 40.0001, but it has to be greater than 40. That's going to leave me with a range after I look at this and this right here. Now, we're going to substitute D, okay, in right there. So my final, range here is that AH is less than 440, okay, but it's greater than 40, okay? And the work I need to show there is right to the left, okay, so that I'm understanding the concept and Mr. Wilcox knows I understand the concept, okay? Because I would rather you guys get it right on the test than to have to go back and watch this video again and get it right on your corrections for only half credit. All right, question number 27, this is lesson 40, finding perimeters and areas of composite figures. We're going to break this up. There's a lot of ways that you could break it up. I mean, a lot of ways I wouldn't do it, but, if we're talking about ways I wouldn't do it, you could make, triangles here and here. You can make a triangle there, make a triangle there, make one big rectangle here, and then you've got all these different little areas, right? You got a triangle, a triangle, a triangle, a triangle, a rectangle, and a rectangle, and you could find the areas of all those things. And then you'd only have to know how to find the area of a triangle and the area of rectangles in order to get your answer right. But I like to use as few figures as possible. Right here, I have a parallelogram. Right here, I have a rectangle. Right there, I have a trapezoid. So if I know how to find the area of a parallelogram, a rectangle, and a trapezoid, that's the way I'm going to solve this. There's a number of ways that you could break this up. A parallelogram, the area gets confused quite a bit with the area of a rectangle. And it's not that it's wrong, but the concept is based around kind of taking this triangle and sliding it over here, because that triangle is the same, it has the same dimensions. So if I cut it off, if I took a pair of scissors and cut it across there and slid it over there, what I would end up having is a rectangle. So that's the formula for a parallelogram and a rectangle is really the same. Okay, so I'm going to take the length 1, 2, 3, 4, 5 and multiply it by the width 1, 2, 3. 5 times 3 is 15. Okay, 15. Rectangle is length times width. The width here is 1. The length is 5. 1 times 5 is 5. Trapezoid takes a little bit more, but not a lot. I think you guys probably already would know some of this, but we know that base 1 is 5. Base 2 is the side that's parallel to that, which is 7, has a height of 2, and we're going to divide by 2. So 5 plus 7 is 12. 12 times 2 is 24. 24 divided by 2 is 12. Okay, so I wind up with 15 plus 5 is 20. 20 plus 12 is 32. But we're not done because we do need to read the question. But 32 will be an answer. It says redwood costs $10 per square foot. We have 32 feet squared, or square feet. We need to multiply that by 10. So we're going to spend $320, okay, for the wood for a deck that looks like that. $320. All right. I'll keep moving. All right, 28. On a sunny day, we have a 3-foot kangaroo. Okay, 3-foot kangaroo casts a shadow that is 5 feet long. Let's go ahead and get our sunny day kind of going there. Let's see. Let's get our grass. Let's see. This is going to be a blue kangaroo. I can draw. Okay, it's a kangaroo, but kangaroo nonetheless. Okay, and it's going to cast, okay, this 3-foot, let's see, the kangaroo itself is 3 feet tall. Okay, cast a shadow that is 5 feet long. Okay, shadow of a nearby eucalyptus tree. Okay, let's. Okay, there's my eucalyptus tree. Let's see. The shadow is 15. Okay, 15 feet long. So it has a 15-foot shadow. We want to write and solve a proportion to find the height of the tree. Okay, now these should both, okay, be similar triangles. All right, so we're going to write a proportion because what we have is a shared angle here, okay, with the ground. So when we have angle, we know that our triangles are similar, which means our side lengths are proportional. What we're going to try to solve is this guy right here. So they don't actually have you, well, I mean, you will solve, but the first part of what they want is to actually have you write out in detail, write and solve a proportion. So what we might do is do tree height over kangaroo height is going to be equal to tree shadow over kangaroo shadow. Okay. I think specifically on this question, they're going to put tree shadow over tree height, okay, which we can do, is equal to kangaroo shadow over kangaroo height, and that's fine. Okay, it's not more correct, but what you want to make sure is that you're not crossing these two things or mixing and matching just any way that you want. So the way I'm going to do this is I'm going to do, let's do it the way that they kind of state in here, which is tree shadow. Well, the tree shadow is 15 feet. Okay, let's see, the tree's height is unknown. We're trying to solve for it. Okay, over the kangaroo shadow, which is 5 feet, over the kangaroo's height, which is 3 feet. So we're going to take 15 times 3 is 45. 45 divided by 5 is 9. So 9 feet is the height of the tree. Okay, obviously my picture's not to scale, as beautiful as it is. I think my kangaroo actually looked better in the other video. All right. Let's see. Number 29. Okay, write and solve an inequality for x. All right. Well, they give me this triangle DCB. In this case, to me, it's not really all that important because what I have on triangle ACD is I have a right triangle where 2x plus 4 is the hypotenuse because it is opposite the right angle. So two things we know about a hypotenuse are, one, that it's opposite the right angle, and two, is that it will be the longest side of a right triangle. And that's really what I'm going to solve here, is that 2x plus 4 is greater than 8. And I have to know that right off the beginning. All right, and then after that, we're solving for x as an inequality. So I'm going to subtract 4. So 2x is greater than 4, and then divide by 2. So x is greater than 2. I want all of that work, okay? I don't want to see just x is greater than 2. If you give me x is greater than 2, I'm going to give you a big fat DSA, and you're going to only get half credit even if you come back and show me the work. Okay, so show me the work. Okay, this would be where if I knew what I was doing, I'd plug in like a clip of Jerry Maguire and somebody yelling, "Show me the money," but show me the work. All right, number 30. Lesson 43, chord secants and tangents. Identify the secant that intersects circle A. What you need to write in here is the definition of a secant. Okay, so you need to know your definitions. You need to know what a tangent line is. A secant is a line that intersects a circle at 2 points. Okay, it doesn't end points because that would be a chord. Okay, secant will intersect a circle at 2 points. So line, not line segment, but line BC is the secant, okay? And what I'm going to write here is that a secant intersects a circle at 2 points, okay? And that's my answer, and that's what I want to see. All right. Let's see. 31. All right. With 31, it says triangle PQR has vertices at 0, 8. Q is 0, 0. R is negative 3, 0. So giving you information that you could see there. S is the midpoint of PQ, and T is the midpoint of RP. We want to prove that the area of PST is 1/4 the area of PQR. They want you to complete the proof for this. So we do know a couple of things, and I'm not saying that I would necessarily do this the same way that the answer key is going to have this, but let's look. I'll try to give you maybe just kind of what the answer key has. They're going to say that first, triangle PQR is a right triangle with height PQ and base QR. Okay, has a height of PQ and a base of QR. And what we see here is that QR is a horizontal line and PQ is a vertical line, which means that's going to make that a right angle, which is going to make it a right triangle. So that's how we get a right triangle in there. The area of triangle PQR. Okay, well, the area of triangle PQR, if it has a base of 3 and a height, P goes up to 1, 2, 3, 4, 5, 6, goes up to 8. So what we're getting there is 3 times 8, which is 24. 24 divided by 2, because base times height divided by 2, is going to be 12. So 12 is going to be my answer right here. That's going to be 12. So we got right triangle area of 12 units. By the what formula, the coordinates s equals 0, 4, and the coordinates of t equal negative 3/2, 4. Well, that's a midpoint formula, which I kind of feel like is unnecessary because they told me the t is the midpoint and they told me the s is the midpoint. But in any case, the midpoint formula is how we would find that. So midpoint would go right there. Okay. Triangle PST is what? Okay, so on 4, we'd also say that this is a right triangle. And if you'll notice, because ST is a mid-segment to this triangle, it's going to run parallel to RQ, okay, with height PS and base ST. So the area of triangle PST, well, if this is 2 and this is 4, then you're getting 2 times 4, okay, which is 8. 8 divided by 2. You should end up getting, hold on, did I get that wrong? No, yeah, I did. Okay, and here's the reason why, is because ST is not 2. Okay, we actually do need to find out what that length is. And so in order to do that, in order to find out what TS is, you need to look at T. Okay, T is -3/2 to the left of S, because S is on the y-axis. So the formula, the work that we're actually showing there, is 3/2, okay, because that's our distance, times 4 divided by 2. So what you're getting there is 3 times 4 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. So your area there is 3. All right, let's see what we can do with the rest of this. So the area of triangle PST, which we already found, is 3. That's what we're seeing there in 5. Let me find my marker. Okay, so we can put that 3 right there. Okay, so since, okay, on 5, 3. Okay, same 5, same 3, is equal to 1/4 of 12, okay, because that's the area of the larger triangle, okay. See what goes on here through the rest of this. I might have to close that out. The area of triangle PST is 1/4 the area of triangle PQR. At the very least, what I need to see on this question is I need you to show me how you found the area of those. Particularly, triangle PQR is going to be fairly easy because you can count your base, you can count the height, you can do the 3 times 8 divided by 2. But on TS, you're going to need to show that you're using that x coordinate of t for your base. Okay, and because it's distance, it's positive. I know it shows up as negative in there because of where it is on the coordinate plane, but because distance is positive, we're using a positive 3/2. Okay, that 3/2 times 4 divided by 2, that's what's getting you that 3. So I need to see that work right there. All right, let's come back up to question 32. We're getting here towards the end. Yay! This is lesson 49, Introduction to Solids. We've seen a question like this. Find a number of faces, edges, vertices for the polyhedron. First thing I'm going to do is count the number of sides. 1, 2, 3, 4, 5, 6. All right, I've got 6 sides. That's going to help me out with the rest of this. Let's see, it doesn't ask for bases. My bases are 2 hexagons, if they were asking. If they were asking to classify this, we'd call it a hexagonal prism because I have 2 parallel hexagons connected by parallel lines. So we're not going to call it, I mean, they're not asking for it, but that's the information there. The number of faces is going to include the 2 bases, plus the number of faces around the outside connected, which are 6 rectangles. So I'm going to end up with 8 faces, because I've got 6 around it, and 1 on either side. So I've got 8 faces. Not me personally, but the shape. Okay, faces, edges. Edges, which are line segments. All right, I've got 6 on each base. All right, so that would be 6 and 6 is 12, and then I've got 6 around connecting. So it's another 6, so that's going to give me 18. 6 times 3 is 18. And then vertices. So these are points. Points like 1, 2, 3, 4, 5, 6. The same thing on this end. 1, 2, 3, 4, 5, 6. So vertices. Okay, it comes out to 12. And if you found faces and edges or faces and vertices and you wanted to use Euler's formula, more power to you. Lesson 32, you could look that up. That's lesson 49, Introduction to Solids. You can find that formula right there. Maybe easy enough just for you to count. That's going to work for me there. Okay. All right, number 33. Find the geometric mean of 5 and 20. Geometric mean of 5 and 20. All right, geometric mean is based upon a proportion, and the geometric mean is going to go here and here. That's where the geometric mean goes. Okay? Anything that's not the geometric mean is going to go top left and bottom right. Okay, so let's use x for our geometric mean that we're trying to solve and cross multiply. So x times x is x squared. 5 times 20 is 100. Square root to find the geometric mean, x equals 10. And we'd see that that was true. 5 over 10 equals 10 over 20 because 5 over 10 is 1/2, 10 over 20 is 1/2. My two sides equal each other whenever I reduce them down. Okay, that's the geometric mean. Okay, you can look up geometric mean in lesson 50 because it may not necessarily be that easy, okay, on the test. All right. All right, number 34. We are getting closer. 34, lesson 51, properties of isosceles and equilateral triangles. What they don't state in this is that we can actually use a lot of stuff from lesson 12 because if you'll notice, I have two parallel lines cut by a handy-dandy transversal, right? So what I should see that's really going to help me out is angles 2 and angle 3 are alternate interior angles. Alternate interior angles, if I go back to lesson 12, if I've got two lines cut by a transversal, then alternate interior angles are congruent. Also, I can see that 117, okay, and angle 3 are same side of the transversal, same side interior angles, and when two parallel lines, my two blue lines, are cut by a transversal, that red line, when I have two parallel lines cut by a transversal, then my same side interior angles are supplementary. Supplementary means they add up to 180. 117 and angle 2 are linear pairs, which means they are supplementary. So no matter what I do, I can solve angle 3 or angle 2 just fine. I'm going to end up using this exact same math. So I'm going to end up doing 180 minus 117, no matter what I do, because I have to do that first. And 180 minus 117 is 63. Okay, 63 degrees. And so I could do that here, say 63 degrees. And because alternate interior angles are congruent, I know that angle 3 is 63 degrees. Okay, so I could show that math twice. I could do 180 minus 117 equals 63, and then do it again, 180 minus 117 equals 63. Or I could state that alternate interior angles are congruent, and then say that angle 3 or angle 2 are congruent. In any case, the rest of what's important here is actually that this is an isosceles triangle. In an isosceles triangle, my base angles, which in this case are here and here, are congruent. Okay, leaving me with only, I got 180 degrees in every triangle, so I'm going to take 63 times 2, which is 126. So 180 minus 126 is going to equal 54 degrees. Okay, so at the very least, that's the math I need to see is 180 minus 117 equals 63, and 180 minus 126 equals 54. Okay, it would be beneficial if you're not going to draw a picture to go ahead and show me how you got the 126. So 63 plus 63 is 126. Okay, as much information as you can give me on your box sheet to tell me, hey, I know what I'm doing here. I'm not just memorizing an answer. Okay, That's going to help me make sure that you don't get a DSA on these questions. Lesson 35, we're talking about 45, 45, 90 right triangles. Lesson 35 comes from lesson 53, aptly named 45, 45, 90 right triangles. So because they tell me that each of these is a 45, 45, 90, all right, I'm going to look at where the 90s are and state that anything in a 90-degree angle is 45 degrees. Okay, 45, that makes that 45, and that 45, this 45, and this 45. So I don't have these great big humongous 45s all over the place. Okay, and I'm going to come down here just as a reminder to you that in a 45, 45, 90 triangle, our ratio is x to x radical 2. So my hypotenuse is equal to x radical 2 every time. Okay. If I know the side adjacent to the right angle, then I know the other side adjacent to the right angle, which means I know that this is 3. And if x equals 3, then x equals 3, then the hypotenuse equals x times radical 2. If x equals 3, then this is 3 radical 2. Okay, which means this is 3 radical 2, because those are going to be congruent to each other, because all 45, 45, 90 triangles are isosceles. Isosceles means that two sides are congruent. The side that's not congruent is the hypotenuse. All right, so now what I have is I've got where I'm seeing this is 3 radical 2 and this is 3 radical 2. So this right here is 3 radical 2 times radical 2. 3 radical 2 times, if you want to, 1 radical 2 is going to be 3 times 2, which is 6. Which means this whole length right here is 6. But if you'll notice, we only want that length from here to here. Okay, so we need to take 6 and divide it by 2. 6 divided by 2, if we were unfamiliar, is 3. Okay, so now what I'm doing is I'm putting 3 is equal to x radical 2. So if 3, sorry, I know my work's all over the place, 3 equals x radical 2, and I want to solve for x, then we're going to divide by radical 2 over radical 2. So if x equals 3 over radical 2, then I need to rationalize that denominator, because I can't leave a radical in the denominator. So we're going to multiply by the denominator over the denominator. We're going to get 3 radical 2. Radical 2 times radical 2 is 2. So x equals 3 radical 2 over 2, and this is your work. Okay? All right, so close to being done. Cannot wait. Number 36. Vanessa wants to measure the width of a reservoir. She measures a triangle at one side of the reservoir as shown in the diagram. What is the width of the reservoir? What we're going to look at here is that y is the midpoint of AC, because we see 100 and 100 on either side of it. And then we see the x is the midpoint of AB, because 120 and 120 on either side of it. And we're going to look at lesson 36, which is lesson 55, triangle mid-segment theorem. What we've figured out then is that xy is a mid-segment. And what I find out from lesson 55 is that two things. One, the mid-segment is going to be parallel to the third side. Okay, the side that it does not touch or intersect. Okay, so it's parallel to that. But also, the mid-segment is always 1/2 of that third side that it doesn't intersect. All right, so what we're saying here is that 150 equals 1/2 of that length. All right, so if I want to find out what x is, all right, I'm going to multiply by 2 over 1. I can't divide by 1/2. Multiply by 2 over 1, so 300 equals x. And so x equals 300 meters. Okay, x equals 300 meters. All right, that's the work we're looking for there. All right, so that should catch you up. That should give you a review worth watching, figuring things out from, and studying for your test, which will be coming up in no time at all. All right, thank you. Hopefully this was helpful. Hopefully it was worth my time to come back in and spend about an extra, I don't know, let's take a look here. Yeah, about an extra, I don't know, hour and 45 minutes to do this for you guys. So hopefully you'll use it and you'll gain something from it, and you guys will have more success on your next test. All right, thanks. Bye.